Hi, I'm Luis Barbosa. We're going to be talking here today about AI and machine learning platform on Azure. Let me share my screen. So within the machine learning platform, it's integrated with many different ingestion and processing sources, more specifically either structural or non-structural databases or projects like Fabric or Databricks and some others. Uh, Also, it has integration with other analytical services. Oh, I'm not sure yet. So yeah, same different integration with Fabric, Databricks, structured database, unstructured database, NoSQL databases. In terms of analytic service, of any different service like uh, Google 360, Power BI, in terms of governance preview, and many other resources, right? And within the core of Azure Machine Learning, we have multiple servers that are enabled to their studio user interface, a client or SDK. Probably going to focus more today on showcasing a little bit of the auto ML features and also the regular notebooks that you can create your own custom-made models. But of course, throughout all the service, you have other capabilities related to performing experiments, data ingestion pipelines, and MLOps features, and also all the infrastructure part, of course, which is fully supported by Azure computational services. All right, so let's see these in practice. So first thing here, we're going to create our resource group, organize everything. Then going to be easy for us once we're going to finish up and delete everything. All right, I have it here. And then let's go to the machine learning service, right? So let's create a workspace associated with the resource group that just created. All right. So it's going to take a couple minutes to execute, and then you can try a very simple example. You could do a classification example, can take a data set here, and you can do this very same example either as a custom model that you're going to create using notebooks, and with notebooks that are available, many different libraries like scikit-learn, PyTorch, TensorFlow, and many others. So I'm going to create a custom model with it. And with the very same data set, we're going to also send it to AutoML, and probably going to get closer to results, because in the case it's going to be a very simple example. But here it is. Let's try an insurance example. Here we have it. You can use this one. A simple fraud fraud insurance example. So I have a label here, target column, which is identify fraud or not based on characteristics of the client or the vehicle. Let's say a copy of it on my local machine. Right. So the the workspace is created. Let's go there. And within the workspace, we're gonna launch the studio. And from the studio, we're gonna see all the resources that will be available. We're gonna, of course, won't be covering all, But anyhow, for today, we're going to talk about the AutoML service plus the custom-made models as notebooks. But I will say there are many other different services and features like data preparation, pipeline for ingestion, environments, deployments, MLOps, all the service related to monitoring and management, experiments, and so many others, right? So let's start with the AutoML, as it takes some time to process and can keep start the job and leave it running and then do other stuff in parallel. So let's create a initial job here. And use the suggested name is fine. And then have to inform what data source we're going to include. Let's use create a data source. Here there is data set. It's fraud insurance data set, right? And it's a tabular data set, and you could connect for many data sources from storage, databases, open data sets, and so on. On our case, it's going to be as simple as a local one. We can select a data store, which is a blob storage. We can use one of the available ones or create a new one if you want. Let's use one of the available ones. It's fine. Upload our file here. Right. Let me double check if it's saved the file correctly. Oh, not really. Let me adjust it and upload it again. Upload it again. All right. Right again. It should recognize correctly. Let's check it out. Yeah, here it is. So we have 3, 4 different features that will be able to help us to predict the classification here, with, which is it's a fraud or not, right? It should be good to go. All right, so let's select a file and then we're going to define what type of task we want here. If you want classification, regression, time series, NLP, or image processing. In our case, it's going to be a classification, right? And you're trying to predict this target column here, this label. In terms of validation here, I guess can be automatically, it's fine. And you can do a train test, play test process. And one last thing that I want to do is to limit the processing time. So you can go back here and finish up everything. So let's limit our processing to 15 minutes. That should be enough for us to come back and check the results. And then in terms of computing unit, we could serverless, but for sure we could create a different cluster, computer units that we could use. We don't have any for now, so let's leverage the server's capability. So as it is, it's fine. And let's submit the job, let it run, and let's do something else in parallel, right? So, all right. Then we could try the very same example, but instead of AutoML service, let's try to create our own custom model using one of the libraries. I'm gonna do something very simple, just as an example, but should be interesting. Um, Before that, just to showcase, let's create a compute unit so can show also this capability. So many different machine types, either using GPU or CPU. Anyhow, let's try a CPU here. Additional configuration in terms of scheduling, spin up and spin down configurations. Let's pretty much accept the defaults and let it create. And then in between, let's create our initial notebook. Yeah, can give a better name afterwards, but initially let's keep name it. So you see, in order to connect our notebook environment to processing unit, computing unit, it's by default connected to the very same machine that you just created, trying to create. And outside of it, it's offering the serverless capability. But let's wait, it's gonna take a couple minutes. It should be more or less same time that you actually type out our code, right? So let's upload it here, the CSV that I'm working with. Um, Here it is, this guy. And then we can do something like use pandas to read this data set, this CSV. Let's keep with our code while the machine is still being created. So once you read the file, next thing we'll have to probably do the idea of the train test split. Um, then you can use sklearn for the whole process here. It's going to be simple enough. Or we can do something like this, called the train test split, that is gonna split your data frame, and then you have to have the separation between what are the features and what is the label, right? So in our case, it should be something like our label. It's the column of fraud, right? And our features should be all columns except fraud. So for our data frame, we could drop exactly the fraud column. And then on the train test split, you can pass exactly the reference to the features, the reference to the label, to the target variable, plus what would be our test size. So let's say that take 20% of this data to test, meaning 80% to train, right? And then it's gonna give us 4 different information. The feature trains for training, the features for testing, the label for train, and the label for testing. So let's give us these 4 information, a tuple with 4 different position. So we could see, for instance, how our testing features look like. All right, and then we could use many different classifiers. We could try maybe a decision tree, which could be interesting as you can visually see the tree. So let's train a tree and then visualize it. So I'm gonna use again the sklearn library. From it, I'm gonna import a decision tree classifier. And let's create an instance of that object. Let's call it tree. Create an instance. Oh, I'm missing a R here. A tree with max of 3 levels, depth 3. And then let's do the training process and measure the accuracy of that training, right? So the the training should be something as simple as the fit operation that get the extra, the features for training, and the label for training. And then if you want to measure the accuracy for that, should be exactly the same. Just the operation, it's called score. So that's pretty much it. And then with the tree trained, we can visualize it using um, using the GraphViz library. Let's import this export GraphViz function. Plus from GraphViz, let's import this source object or class, and then we can use the export GraphViz to visualize the to create the data object of the tree, and then pass it to this, create an object of this class that actually want to create the graph of the tree. Anyhow, parameters here, you can have the model itself. We could have a parameter here to make it colorful according to the classification. You can say fill it through. Then you can ask to use the feature names, which is pretty much the training column name. And lastly, we could define what are the values for the label values, right? In our case, it's not fraud or a clean record or okay record, it's 0, and our signaling of the fraud, it should be signaling as 1. So we'll have something like class names. So in case it's 0, we'd say that it's going to be okay. In case it's matched with 1, we can identify it as a fraud. So yeah, that's pretty much it. I believe the computing, yeah, completed its creation. It says it's executing. You can use multiple kernels. Probably use like this one would be interesting because most of the libraries should be in there. Azure ML, so things like graphics should be available. In case we are working with like TensorFlow or PyTorch, maybe could use this one. But yeah, and of course here I'm working with Python. In case you are working with R, this could be an interesting kernel. So let's try this one, and it's requiring us to authenticate. Let's just click it here, and it should be fine. Let's see. You can read. Let's execute all of our code. .tsv. All right, here we have the file, and the train pass split. Yeah, you still only have here you have the 4 features plus the label, and here we only have the features for testing, which are less rows, or original file have like, I don't know, 100 rows, 1,000 rows. Anyhow, let's train our tree. And throughout the training process, it got 68% accuracy. It's not that great, but I guess it's good enough for now. For a simple example, let's try to visualize our tree. Oh, so it's complaining that it's not available. Let's try to install the library. We have this. Oh, maybe it's still missing the binary of this. Let's try to up apt install also that. Mhm. Here we have it. So again, our model is simple enough. It's detecting fraud by oh, that's yeah. That's how the interpretation. People with age above 85, 83, it's most of the case here, it's registered as frauds. Younger people below 46, uh, between 17 and 46, a bunch of fraud cases also. And very young people in general were not frauds. And people between 46 and 83 that has a larger engine sizes are not historically registered as fraud cases, right? I'm not really discussing the data here or the validity of it. It was only a simple test example, right? Long story short, our very simple custom-made model, we had like a training accuracy of 68%. Like keep that number in mind. So we're going to compare the kind of results and what actual kind of model, because could use many different classification models here, right? The AutoML going to try multiple of those and then try to get the best accuracy for any of those and deliver to us and recommend to us whatever it finds. So let's see what it finds. It still had some time to finalize. It should have still a couple minutes. In between, I can show a little bit of overall AI platform, right? More specifically, what the Gen AI part here cover some of the feature of the machine learning part. So as AI services, of course, one important service at this point is OpenAI service, which is interesting enough to have a private hosted OpenAI deployment already fully available within Azure. But not only that, search service, speech, video, saved document processing, language process, translation, all the kind of models are fully available. And within GenAI and LLM space, there are multiple models beside the OpenAI ones. So all of those, so within OpenAI as a service, you have GPT-4, GPT-4 Turbo, 4.0 actually, GPT-4 Turbo, and then these models, DALL-E, and some others, but not only the OpenAI one, and as you know, Azure currently has a strong relationship with OpenAI, investment relationship. So it has other models from Microsoft, from Meta, from Mistral, Snowflake, Databricks, Hugging Face, and many others, right? So let's play around with some of these, especially with the OpenAI ones. And in order to do this, we gotta enable the OpenAI services. Let's go back to our console. Look for OpenAI. Here it is. We're gonna create an OpenAI environment for us. Right. It should be a unique name. This should do the trick. All right. Validated. Created. It's deploying. While it deploys, let's just take a quick peek how our AutoML is going. It's still running. So yeah, it should take a couple more minutes to finish up. In between, let's yeah, let's move for the for OpenAI services. Right. Here it is. Let's open up within our environment what they call it. What they call it? AI portal, AI Foundry portal. Within here, you can play around. I don't have any deployments, but you can deploy models, play around with a chat interface, and not only that, we can of course integrate through APIs. So let's try to deploy a model. So let's go here to deployment, deploy a model. We try something not so expensive, maybe something like 3.5 turbo, maybe. Yeah, could be enough for a little experiment here. All right, here have the model. We have the endpoint, the key. We're gonna copy that, try to connect to it. So yeah, let me copy it here. Endpoint, the API key. Right. We could again play around with the regular user interface. Complain about endpoint. Let and I guess it's deploy right? Yeah. And, uh, yeah, it may be the older version that's going to be decommissioned. But anyhow, even through the API, we may be able to use it. It even says here, um, it's showcase here an example code. Um, all right, let's try to use it from a notebook. Be even the very same notebook as we have it here. Yes, it's fine. So we could do something like probably have to pip install the OpenAI library and then create a client. Throw my keys in here. All right, and then let's try to connect to it and run a couple of dialogues. So yeah, can ask whatever, create a context for the chat, open a message and see what it responds. You can adjust temperature, number of tokens, and let's bring out whatever the model responds back to us. So yeah, that's its response. We could add something even simpler as I was trying to do. While the kit, let me double check it here. Oh, probably already hit a limit of tokens. And just to check it out, where to adjust this. Yeah, 1,000, I guess. Anyhow, so the API it already responded, right? You are familiar with the kind of interaction that you can do with LLM in the simpler model as GPT 3.5 here, but you get the idea, right? So it's a fully deployed OpenAI model within a secure Azure environment, in which probably throughout all other Azure resources gonna be hosted the rest of the client um, solution, application, or whatever is doing in this case. So it's convenient enough and secure enough, have the models and all application resource and deployments within a single environment. Also, from the management perspective, it's quite handful. Um, all right, let's finally go back to the auto training. AutoML. Let's hope if it's finished at this point. Um, Should be finished at any moment. We'll set up something like 15 minutes. It's a little over that by now. And I hope it beats our mark, right? We got something like 68% accuracy. So it used a couple of different techniques at this point, I believe. Yeah, still finishing up. While it finishes, let me see if I can deploy yet another model. I hope I have enough credit. Yeah, no, I don't. That's what I feared. It's fine. All right. Yeah, it's activated already. I have to wait a couple of minutes also. Um, so max it out on tokens already. All right. And yeah, it's only a token limitation. It's fine. And yeah, finally the auto ML training completed. And then you have it, right? You can see that it created an ensemble model to beat us. It used AUC as a metric. Probably can see other detailed metrics in here. Let's do something better. Let's drill down on the best model that it could find. And yeah, within here. So from here, could deploy into production, test with other data and so on. But just check it out on some of the other metrics. So, actually didn't beat us on accuracy. Our simple model got a better accuracy here, which is fine, I guess. Um, but yeah, overall, that kind of thing that you have with AutoML, you can see we could have done also with AUC rock curve, confusion matrix, could have done that back in our custom model. But anyhow, just the kind of idea what you can do here from the platform. And again, once you have trained model, you can do all the ML ops operations in order to deploy, to keep fine-tuning the model, management it capacity in terms of cluster and nodes to be serving that model, depending who would be consuming, if it's an external application or and depend how many requests per minute. So many different variations, right? So in summary, just to recap, we see a little bit of the capabilities of Azure Machine Learning, which again is connected with many data processing platforms like Fabric, Databricks, structured databases, NoSQL databases, unstructured also data, analytic tools like Power BI, Databricks, and others. Data governance capability integrated with Microsoft Peer View, and through three different access ways. We use the user interface, the studio interface, but always have the CLI command line and SDKs, and we focus on notebooks and AutoML, but again, we have all the experimentation, ML flow, pipelines, ML ops, plus all the infrastructure. We use it both several methods and also a little machine that we created here, but everything that's available in terms of infrastructure management from Azure, it's fully available and integrated here, of course. And then that's the ML part, right? ML, it's a part of a larger umbrella, which is AI, and within AI, besides ML, we have all the Gen AI models and services, plus search capabilities, speech capabilities, image process capabilities, safety, document process, language, and translation. And within this box here of LLMs and GenAI models, we have out of the bat the OpenAI ones, more specific some of the examples here, GPT-4o, GPT-4 Turbo. We play around with GPT 3.5 as it's shown here. Embeddings, DALL-E for images, so many others, and not only the OpenAI ones, but some from Microsoft, from Meta, from Mistral, from Hugging Face, Databricks, and Divya, and Snowflake, and so on. All right, I hope you like it, and see you next time.